Hi, I'm Sydney Wright, and today I'm going to be explaining how to do a geometry prompt. So first, I like to read through the prompt. So it says, prompt, given that A, -3, 3, B, 1, 5, C, 4, -1, and D, 1, -5, prove that ABCD is a right trapezoid. So what I like to do first is then just to read through step 1, which is create a visual and gain information and brainstorm. So basically, we're going to plot our points. So once I have all my points plotted, which I do here, A, B, C, and D, I am then going to just connect the points with a line. So then we need to look at our shape and say, what must a right trapezoid have? What is a right trapezoid? So a right trapezoid, I'm just going to turn it this way because this is how it should be facing. A right trapezoid must have 2 right angles, one here and one here, and also must have at least one set of parallel lines, which, as we can see, is here and here. So we now determine that it is, or we believe it is, a right trapezoid, rather than being a false statement. So then we move over to here, which is step 2, statement of intent. So identify what you are going to prove, what mathematical facts you are going to use to prove it, and how you will know that you have met the burden of proof. Use if, then statement where applicable. So why don't we think a little bit deeper into this? So first we want to kind of say what we're going to use to find certain aspects of our quadrilateral. So since we have 2 right angles and 2 parallel lines, or we supposedly do, we need to think about what we can use to make sure that those are true and to prove that they are true. So what I was thinking is that we can use the slope formula to find if these 2 lines, AD and AB, are perpendicular, and to see if BC and AD are parallel, because if these 2 lines are perpendicular, they will create a right angle. So go back to this section, the statement of intent section, we can go ahead and start to say that we're going to use the slope formula to prove that the certain lines are this and the certain lines are that. So let me go ahead and write that down. So the first part of our statement of intent, I wrote, we are going to prove that ABCD is a right trapezoid by using the slope formula to show that AB is perpendicular to AD and that BC is perpendicular to AB, which would form the 2 right angles that we needed. So that's the first part of my statement of intent. Then I'm going to move into the part where I'm going to say that we are using the slope formula to also show the parallel line part. So let me go ahead and write that part down. Then I just went in and said that also we are using a slope formula to show that BC is parallel to AD. And yeah, so once I'm done with making these 2 parts of it, we are then going to put in our if-then statement. So I'm going to go ahead and write down that if line segment DA is perpendicular to AB and AB is perpendicular to BC and BC is parallel to AB, then ABCD will fit the definition of a right trapezoid. So yeah. So once we finish the step 2, statement of intent, which we have, we are then going to move on to step 3, which is proof body, which is to perform all mathematical calculations and or logic chain of events. This is a formal version of what you roughed out on the graph. So on this part, since we are using the slope formula, I'm just going to use the slope formula for line AB, line DA, line BC, and line DC, and it should prove the points that we needed about the perpendicular and parallel lines. So first we're going to find AB. So to use the slope formula, we first just need to write it up here. So it's y2 minus y1 over x2 minus x1. So if we just plug in our numbers for AB, it's going to be 5 minus 3 over 1 minus -3, which is just plus 3. So then we can simplify that. So 5 minus 3 is 2, over 1, and then plus 3 is 4. So that equals 1/2 for AB. Next, we'll move on to line DA and just plug in the numbers again. So we're going to go with 3 minus -5 and -3 minus 1. And then we're just going to simplify this down. So 3 minus -5 is just 3 plus 5, which is 8 over -3 minus 1 is -4, so that's -2 over 1, which as we can see is the opposite reciprocal of this, which proves that they are perpendicular lines, and also proves one of our points about us needing a right angle, or 2 right angles. Next, we're going to find BC, which we're just going to plug it in one more time. So it's going to be -1 minus 5 on top, and 4 minus 1 on bottom. And then simplify it down again. -1 minus 5 is -6 over 4 minus 1, which is 3. Then we can simplify that back down to -2 over 1, which as you can see over here is the same. -2 over 1 down here, -2 over 1 up here, which means that they are parallel, which is also what we were trying to prove earlier, that BC and AD or DA is parallel. And then lastly we'll do DC, which actually really doesn't matter as much in this case, just because we aren't looking for the value of this, but it's good to just see and find out what this value is. So I'll just plug and chug, and we'll end up with -4 over 3, which is just a random number, which we aren't really concerned about. And then last, we have step 4, conclusion. So you're going to explain whether or not the prompt is true based on your statement and intent of the proof body. So we can go ahead and think a little bit about if it worked, if what we did worked, if this matched up, and which we saw in this section, step 3, we did see that it ended up working. So we can go ahead and just explain that it did work, and that what we guessed in the beginning is true. So then on the bottom, I decided to write, because line DA or AD is perpendicular to AB and BC is perpendicular to AB, they form 2 right angles. Also, because line BC and AB's slopes are the same, they are parallel, which is our first intention that we started with in the beginning. So yeah, we completed a proof from step 1 to step 4. It's pretty simple, and it's a really good way to figure out what you're doing right and wrong. So thank you guys for watching.